Hello friends. So in this video, since in the last video we have already seen how to use the semaphore, so in this video what I'm trying to do is we'll try to see how we can profile the basically execution, how we can profile the execution of any function, or how we can measure the time of any section of code. So basically profiling the execution time of any C functions. Okay, so that's what we'll try to do in this video. So here what I will do, I will try to write a function uh, using which will be calling to basically get the time in CPU clocks, get the time in CPU clocks, how many CPU clocks it has taken. Okay, so that will be helpful for basically measuring any time related parameters, like suppose we have to measure any interrupt key, how much execution time, how much time is being taken by the interrupt. So those kind of things we can measure, or after how much time the task switching is happening, that also we can measure. So basically it's an utility tool. Okay, uh, and that utility tool will be very helpful in measuring, in profiling the execution of any function. Okay, so mm, let's uh, let's go to the we can add in FreeRTOS config. Okay, FreeRTOS here we will just add one function, and that function will be initializing the performance monitor counters in the ARM CPU. Okay, so the basically those counters will be increasing at the CPU clock, and based on that we will try to profile how much time any function is being taken. Okay, so let's start that function. We'll declare is static void, then that function name we can give it as a uh, initialize uh, more performance monitors. Okay, performance monitors, and basically here we will uh, be it is already suggesting some register. Let this msr pmu snr el0, that we are writing it as 1, and then we are resetting all counters to 0. Okay, this is fine, but apart from this, basically msr we are reading this inside, we are writing this, right, reading this one bit. msr is for writing it. Okay, and after writing this we also have to basically read it. For reading we have mrs registers, so that also function we will try to basically copy it. Okay, so this is for reading that PMC counter, and I think let's copy that another one also, which will be enabling uh, this performance monitor counters. Okay, Yeah, so with this it completes these two things. We will be initializing that performance monitors and then reading the counters. Okay, so uh, after this we have to also put the declaration inside declaration inside one of the file. Okay, let's put that. So we have .h. Yeah, so void is needed. Okay, so this one, and we will put it for this one also. uh, okay, now let's try to compile it. Is it showing some any other warning? No. And we'll use this inside main.c. okay, inside main.c before doing any task start. What we try to do, we'll try to profile some of the things, right? Okay, so we'll try to profile here. We'll try to start that timer in the starting, so that function what initialize performance monitors, and basically we'll try to profile any word print, how much count it is taking. uh, let's profile this test function. Okay, so to profile it we have to basically take one uint64 time, and that uint64 will take one timer which will tell the start of it, basically start, and it will basically start, will read it, and the same thing we'll do at the end, and then print the difference. Uint end of this cycle and printf to end minus start. Yeah, so using this we'll try to see how much time is being taken by this printf function. Okay, so let's do clean and build it again. Yeah, so we have built it now. This function will be very helpful in profiling any kind of interrupts, okay, in any kind of functions. Okay, so after building this we'll transfer this to tftp. Okay, after transferring it to that system, let's open the picocom, and we'll see what is getting printed here. Okay, so let me power on this rpy3b. Yeah, so we are getting this u-boot console. Now let's load it. 0x8123 kernel 8.img. So after loading this, let's read some of the bytes, and after that we'll jump to that location. Yeah, so I am killing it just to see how many ticks we have got. So here printf took almost these many cycles. Okay, so the CPU in ARPAI 3B actually takes let me find out. CPU runs at what speed? CPU at ARPAI 3B runs at what clock rate? So it runs at 1.2 gigahertz, and that 1.2 gigahertz, for 1.2 we have taken these many cycles. So to measure exactly how much time it took, what you can do, let's open calculator. So okay, let's open scientific calculator, and let's try to see. So 1 divided by 1.2, so these many, basically nano is 10 power 9, right? So these many nanoseconds. Okay, this nanosecond you have to multiply with 5691510, sorry, and 5691510. So these many nanoseconds it took to print. So nanoseconds, then basically microseconds, then 4.7 milliseconds. So the print actually took 4.7 milliseconds to print this complete. Okay, so this is how we can profile any function or any code section. Okay, so this utility will be very helpful in profiling. That's all. So here we'll try to close this video. Thank you.